Link sharing.
Game.
అది ఎందుకు పని చేయట్లేదు అంటే అదేదో సాఫ్ట్వేర్ అని అడుగుతుంది. చూసారా చార్జర్ మొత్తం అందించారా?
Good evening all. Shall we start? Yes, whoever is online, please post your questions in the chat box. Your questions, any doubts and answers in the chat box, please. Okay, so going with question number 1. Question number 1, name the class of immunoglobulin which takes part in hypersensitivity reaction. Name the class of immunoglobulin which takes part in hypersensitivity reactions. And the options are IgG, IgE, IgA and IgM. So what's the answer? Whoever is online and whoever is attending live, please post your answers in the chat box. What's the answer? Okay, let me confirm, am I audible? Let me confirm, am I audible? Okay, thank you very much. Yeah, thank you, Naveshri. Okay, so we are going to the first question. Name the class of immunoglobulin which takes part in hypersensitivity reactions. So to attend more number of questions, to finish more number of questions, I think we need to attend question by question in a bit faster way. So Yes, post your answer in the chat box. Post the option of answers in the chat box, please. Answers in the chat box. Okay. Yes, yes. Option A, option B, IG, and option B, yes, IgE, and the answer is option B, IgE. Okay, and the answer is option B, IgE. Why? So totally we usually have totally 5 number of antibodies. They are IgG, IgE, IgA, IgM, and IgT. Okay, and the immunoglobulin which is responsible for hypersensitivity reactions is IgE. Okay, and IgG. What about IgG? What about IgG? What kind of an immunoglobulin is it? What kind of immunoglobulin is IgG? IgG is usually is the immunoglobulin which is responsible for opsonization, that is identification, and which is responsible for complete removal of antigen from the body. Okay, so IgG it is usually it involves in 1 second please. IgG enable editing and
మాట్లాడు.
కానీ అది రావట్లేదు కదా.
అక్కడ 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 వస్తుంది మేడం, అది గుంజుకోండి తీసేనా
So sorry for the inconvenience. So IgG, the first option IgG, so this IgG is responsible for opsonization. It is responsible for secondary response, and it is the positive factor for opsonization, that is complete removal of the antigen or the whatever the bacteria or virus, whatever may be the type of antigen, It is responsible for complete removal. It opsonizes the antigen. That means opsonize means it changes it. It acts as it adds opsonins, and it is responsible for complete removal of the antigen from the body. Okay, so this is responsible for secondary response. And IgE, just now as we have discussed, it is responsible for hypersensitivity reactions, that like allergies and all. Okay, IgA it is usually found in body fluids. It is found in body fluids. IgA is usually found in body fluids. It prevents the attachment of bacteria. Actually, this prevents the attachment of bacteria and viruses to the cell membranes. And last one is IgM. IgM is the largest antibody which is present, largest immunoglobulin present in our body. It is a pentameric antibody and it is the largest antibody. IgM is responsible for first line of defense, first response or first line of defense. Okay, whenever an antigen attacks our body, whenever an antigen enters the body, any kind of antigen which is released from bacteria, virus, fungi, whatever it is, any kind of antigen, any foreign material, when it enters our body, what happens immediately? The first antibody, first immunoglobulin to respond is IgM. It is the largest antibody present in our body. Okay. So, and the answer to this question in immunoglobulin which takes part in hypersensitivity reactions is IgE. Okay, and we'll move on to the next question. Moving to the next question. And the second question is, name the type of culture which is prepared by inoculating directly from tissue of an organism to the culture media. Okay, name the type of culture. So when we prepare various microbial cultures, so name the type of culture which is prepared by inoculating directly from the tissue of an organism directly to the culture media. So and the options are primary cell culture, secondary cell culture, cell lines, and transformed cell culture. So what is the answer? Answer for this question? Direct answers, please. Direct answers, option A. Okay, option A, primary cell culture. Yes, and the option is option A, primary cell culture. Okay, so primary cell culture, how is it? So as the name indicates, directly we are inoculating the tissue of an organism into the culture media directly. Okay, so and that gives a primary cell culture. In primary cell culture, there is no proliferation, there is no cell division, no proliferation, only pure cells, completely the pure tissue or pure cells. Okay, and what is the secondary cell culture? What is the secondary cell culture? Secondary cell culture, it is formed from, it is originated, or it can be generated from primary cell culture by proliferating the cells. Okay, by just removing the cells or removing the tissues and going for proliferating them, we get a secondary cell culture. And what are cell lines? What about cell lines? Anyone? Any answers? Any answers? Cell lines. What are cell lines? Cell lines are also cultures of organisms, but which are respective to. We are taking an individual type of cell. In a primary and secondary culture, there is no distinction. There are infinite number of cells. Okay, infinite group of cells. But in cell lines, what happens is a certain type of cells are separated and they are grown separately. They are grown or cultivated. They go to proliferation separately. So that such type of cultures are known as cell lines. In cell lines are homogeneous cultures. All the remaining primary and secondary and transformed cell cultures, they are heterogeneous cultures. But cell lines, they are homogeneous cultures which contain only a single type of cells or single type of tissues. Okay, and what is a transformed cell culture? A transformed cell culture is a type of cell culture in which cell division is induced. Okay, like type of cancerous or tumorous growth is induced. Such type of cell culture is known as a transformed cell culture. And the significance of transformed cell culture is it consists of infinite division. It is infinite, no finite cells, infinite number of cells, infinite division. Because there is a gene mutation. Because in transformed cell culture, what we do, we induce a gene mutation. So by that way, this undergoes infinite division, which is responsible for cancerous or tumorous type of malignant growth, unstoppable growth, uncontrolled growth. Okay, so directly from the tissue of an organism, the culture we obtain is a primary cell culture, and this is the remaining information about the remaining options. Hope this is okay. Hope this is okay. Shall we move on to the next question? Okay, and the next question. Question B. A positive tuberculin test is an example of a positive tuberculin test. When a tuberculin test it is performed for identification or diagnosis or detection of tuberculosis. Okay, whether the tuberculosis antibodies are present within the body or not. That is tuberculin test. Okay, so a positive tuberculin test, when it is positive, it is an example of what? Okay, and the options here are A, delayed type of hypersensitivity, B, acute contact dermatitis, C, type 1 hypersensitivity and anti-eczema, and D, eczema. So what's the right answer? The answers in the chat box. Yes, my voice is not clear. Sir, is there any adjustment? My voice is not clear. Is it okay now? Is it okay now? Yes, now? Okay, thank you very much. Okay, and the answer is a positive tuberculin test is an example of, and the answer is, voice is clear now. Okay, thank you very much. Thank you. Yes, please let me know in case of any disturbances in between. Please let me know in the chat box. I think it is okay now. Please tell me the answer for this question. Answer for this question. Yes, some answer. Okay. Yes, and the answer is a delayed type of hypersensitivity reaction. Okay. So, on the whole, how many types of hypersensitivity reactions are there? How many types of hypersensitivity reactions are there? There are totally 4 types of hypersensitivity reactions. Okay, totally 4 types of hypersensitivity reactions occur. What are they? Type 1, type 2, type 3 and type 4. Very important question regarding hypersensitivity. It is a very important question. The types of hypersensitivity, examples of the diseases which exhibit these hypersensitivity reactions, and the mediators of hypersensitivity. Mediators of each type of hypersensitivity, very important. Okay. So, what is type 1 hypersensitivity? Type 1 hypersensitivity also known as immediate hypersensitivity. So wherever you have a question like immediate hypersensitivity, so don't get panicked or don't get confused. It is nothing but type 1 hypersensitivity. It's also known as immediate hypersensitivity reaction. Okay, and the mediator for type 1 is, what is the mediators? Mediators of hypersensitivity. Yes, it is called immediate hypersensitivity because it exhibits a rapid reaction. Yes, very good, right. What is the mediator for immediate hypersensitivity? Mediators are also equally important. Please note down or please concentrate. Okay. The mediator for type 1 or immediate hypersensitivity is IgE. IgE is the mediator for type 1 hypersensitivity reaction. Okay, what are the examples? Examples of immediate hypersensitivity? Examples of immediate hypersensitivity? Yes, common cold, cough, eczema, allergic reactions. Whatever the allergic reactions which occur in response to, yes, cold, cough, and any allergy, rashes, eczema, dermatitis. These all come under immediate hypersensitivity. Like when we are sensitive to any antigen which sensitizes our body, and our body immediately reacts to it. It is known as immediate hypersensitivity. Okay, and it is mediated by IgE. And type 2 hypersensitivity. Type 2 hypersensitivity is mediated by. It is mediated by IgM. The mediator for type 2 hypersensitivity reactions is IgM. Okay, and the examples for type 2 hypersensitivity is blood transfusion reactions, hemolysis reactions, and blood transfusion reactions. Blood transfusion reactions. Okay, and type 3 hypersensitivity. Type 3 hypersensitivity is mediated by antigen antibody complexes. The mediators, I'm telling you, I'm repeating so many times, mediators of hypersensitivity reactions is very, 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 very important. Any competitive examination point of view, very, very important. Is mediated by antigen antibody complexes. And the example for type 3 hypersensitivity is arthritis. Okay, and type 4 is delayed hypersensitivity. Just now we have discussed a positive tuberculin test. Our option, our right option, delayed hypersensitivity is termed as type 4 type of hypersensitivity. Delayed type of hypersensitivity reaction. Okay, so it is delayed. It is called delayed because the hypersensitivity, that means when an antigen enters our body, like we have seen in immediate hypersensitivity, an antigen enters the body and immediately our body responds to it. In case of delayed hypersensitivity, as soon as an antigen enters our body takes certain time like days, like until days, to react to this particular antigen. That is why this is known as delayed type of hypersensitivity reaction. Okay, and the example, and the type 4 is mediated by type 4 hypersensitivity. It is mediated by is the board completely clear, visible, completely clear? Screen. Type 4 is mediated by T cells. Okay, so when a question appears like T cell mediated hypersensitivity reaction, then the answer should be type 4 or delayed hypersensitivity reaction. Okay, it is mediated by, the mediator here is type 4 is T cells. Okay, and the examples for delayed hypersensitivity reaction is tuberculin test, graft rejection reactions in case of okay, fine. Rejection reactions in case of transplantations, organ transplantations, grafts. So we usually observe some kind of rejection reactions. That is an example of delayed type of hypersensitivity. It usually takes some days for the reaction to occur. Okay. So this is how this positive tuberculin test, it is also known as tuberculin test, is also known as Mantox test. Okay, this is how it is performed. Okay, a small sample here, as we see, a small sample of this tuberculin virus, tuberculin bacterium, a culture is injected into the body, into the hand, dorsal part of the hand usually, and the reaction is observed. What happens? for after 2 to 3 days. After 2 to 3 days, if there is a tuberculin antibody in our body, we can observe the reaction. Like we can clearly see here, like reddening of the skin, erythema, swelling. All these reactions can be observed after 2 to 3 days usually, and more also sometimes. Okay, that tuberculin test is also known as Mantox test. This is also very important. Please make a note. Okay, moving forward to the next question. The process of finding the relative location of genes on a chromosome is called process of finding the relative location of genes on a chromosome. So we all know that the chromosomes are coded by genes. So the process of finding the location of genes on a chromosome is called what? And the options are A, gene tracking, B, genome walking, C, chromosome walking, and D is genome mapping. So what is the right answer? What is the right answer? Oh yes, I got some answer. D is genome mapping. Option D. Okay, is it genome mapping? Option D, option D. Many option Ds. Okay, so you're all very clear about it. Very clear about it. And the option is yes. And the answer is option D, genome mapping. Okay, so you people might have correlated the word location with that of a map, right? No? So whenever we talk about some location, even in some Google Maps or something, when we speak about location, we immediately get reminder of something like a map, right? So you people must have correlated. Yes, that's a good correlation. Of course, correlation is important too. Okay, yes, good, nice. Sometimes that correlation works. Okay, so finding relative location of genes on a chromosome is called genome mapping. Just like similar to finding a location on a Google map, we are finding the location of gene on a genome map. Okay, so why can't it be gene tracking? What is gene tracking then? What is gene tracking? Okay, we'll discuss that later. We'll discuss. Right now we are discussing on this. We'll focus. Let us focus. What is gene tracking? What is gene tracking? Okay, gene tracking is nothing but, so because it is finding location can also be tracking. So it is slightly confusing whether it can be tracking or mapping. Okay, so what a gene tracking is? Gene tracking is the tracking or finding the inheritance of a gene in a family. Okay, sometimes we see in some congenital disorders or in some inherited disorders, we usually see some in some after some generations we observe some disease is prominent. Okay, so whether to find out whether this particular disease it is because of inheritance or because of certain other factors, this gene tracking is used. Okay, so in this what they generally do, they track the genome of the complete family, whether the gene is being inherited or not. Okay, whether if it is inherited, then we can call it a congenital or inherited disorder. That is gene tracking. Okay, so shall we move on to the next question? Moving on to the next question. Yes. So this is a gene map. Okay. So this is how genetic mapping is done. So we are finding the location of genes. This from this location to this location, this location to this location. What is the genetic map? So in this way, this is known as the genetic or genome mapping. Finding the DNA sequence. We are finding a particular area or location, and then we are coding that particular DNA sequence. Okay. So moving on to the next question, question number 5. Which of the following enzymes in bacteria are responsible for restricting the growth of viruses? Okay, this is the question, and the options are: which of the following enzymes in bacteria are bacterial enzymes responsible for restricting the growth of viruses? Okay, so what are they? Options are: A, restriction endonucleases, B, topoisomerase, C, gyrase, and D is protease. So what's the right answer? Yes, what's the right answer for this question? Restriction endonuclease. And any more answers? Any more answers? Okay, most of you have given the answer to be A. Let's see what's the right answer. Okay, and the right answer is restriction endonucleases. Okay, what do restriction endonucleases do? Restriction endonucleases are the enzymes which are present in bacteria which restrict or which stop the growth of viruses within them. Okay, so how do restriction endonucleases act? What is the mechanism of action of restriction endonucleases? Please try to correlate. Don't read a particular point. We have seen a particular question. Yes, how do they limit? How do they limit? By restriction endonucleases, they prevent or restrict the growth of viruses by cleaving their genetic material. By cleaving the genetic material. Cleavage of genetic material, viral genetic material. By cleaving the viral genetic material. Okay, so this is how restriction endonucleases act. Even this is very important. Knowing the enzyme is equally important, and knowing this, its mechanism of action is more important actually. Always, whenever you come across an enzyme, an antibiotic or whatever, you always try to correlate their mechanism of action. That is equally very important. Okay, and what does the topoisomerase do? So you please remember all these mentioned here, A, B, C, D, all the enzymes mentioned here, they are responsible for attacking the viruses. So what are the viruses? Do viruses attack bacteria? Yes, please answer. Do viruses attack bacteria? Viruses bacteria attack chestaya? Both are microorganisms. Do viruses attack bacteria or not? Yes. Will they attack or not? If they attack, what are the viruses that attack or that infect? Yes, what are the viruses that infect bacteria known as? The viruses that infect bacteria are known as bacteriophages. Bacteriophage. Yes, it is known as bacteriophage. Okay. So all the enzymes here mentioned, restriction endonuclease, topoisomerase, gyrase, protease, all they are responsible for attacking the viruses. But every enzyme has their own mechanism of action. Okay. So how does a restriction endonuclease? It cleaves the genetic material and prevents the growth of virus. Okay. So how does the topoisomerase act? Yes, bacteriophage, very good. How does the topoisomerase act? What does it do? A topoisomerase, it prevents the tangling of DNA. So we all know that a DNA or a genetic material, it is active only in its tangled or coiled form. Okay, when it is in a double helical structure and it is in a tangled form, it is active and it promotes further replication, further growth. Okay, so what does topoisomerase do? It prevents the tangling of that particular DNA. So by preventing the tangling of DNA, it prevents the further growth or further replication of viruses. Okay, it prevents tangling of DNA. Okay, so what does a gyrase do? What's the mechanism of action of a gyrase? A gyrase, DNA gyrase, what does it do? It helps in winding and unwinding, same coiling, winding and unwinding of DNA. Gyrase helps in winding and unwinding of DNA. What does a protease do? Protease, how does it act? We all know that very well. Protease, it breaks the peptide bonds. It breaks peptide bonds of proteins, and so it restricts the further growth of viruses. Okay, so here the right answer for this question is restriction endonucleases. Gyrase, yes, it is a type of topoisomerase. Yes, it is a type of topoisomerase. Okay, shall we move on to the next question? Moving on to the next question. Yes. Methicillin resistant Staphylococcus aureus, methicillin resistant Staph aureus, MRSA. So there are certain statements given with respect to this MRSA. So we have to identify which one is right. Which statement is right with respect to this methicillin resistant Staph aureus strains. Okay. And the options are: option A, it is usually sensitive to vancomycin. Option B, it is more likely to cause deep-seated infections. Option C, it is often resistant to many staphylococcal antibiotics. And option D, it may cause asymptomatic colonization. What is the right answer? Right answer for this question, methicillin resistant Staph aureus, what does it do? What does it do? Yes, option B. And any more answers? More answers, please. More answers. And the right answer is yes, it is more likely to cause a deep-seated infection. Yes, deep-seated infection. Yes. Very good. Very good. Why? Why? Okay, yes, staph bacteria, usually Staphylococcus aureus, it is a type of bacteria, and the most of the Staph aureus infections are usually treated. The first choice of drug for treatment of Staph aureus is first choice of drug. They're usually treated by using penicillins, like methicillin. Methicillin is the first choice of Staph aureus infections. Okay, but there are certain strains of Staph aureus. There are certain other substrains of Staph aureus, Staphylococcus aureus, which are still resistant to methicillin. Okay, so what usually happens whenever we are prone to any Staph aureus or any kind of infection, and when we visit a doctor, what usually happens? A doctor first prescribes before going to final examination and all. What they usually do? They usually prescribe a first choice of drug. So first choice of drugs are usually penicillins. Usually penicillins like methicillin, amoxicillin. Usually penicillins first line of treatment. Okay. So meanwhile, if the particular Staph aureus bacteria, yes, if the particular Staph aureus bacteria it is resistant to methicillin, so then what happens? If the infection is not gone, it is not cured, and meanwhile, by the time the first line of antibiotics finish their mechanism of action, what happens? This infection becomes deep-seated. It becomes deep-seated. Meanwhile, means it increases. Okay, so this methicillin-resistant Staphylococcus aureus is usually more likely to cause a deep-seated infection. Okay. Yes, and what is the drug of choice? Second line of choice. Second choice for Staph aureus infection. The first choice is just now we have discussed. It is penicillins mostly, methicillin, amoxicillin, and all. Second line of choice is second line of drugs is vancomycin and anti-staphylococcal antibiotics like clindamycin, vancomycin. All these drugs are used as second line of when the first line fails. First choice of drugs fail, then we'll go for second choice of drugs, that is vancomycin. Then we'll come to know that this is resistant to methicillin. Meanwhile, what happens? దాని పని అది చేసుకుంటుంది. Yes, linezolid. Okay, meanwhile, ఏం చేస్తుంది? This Staph aureus, it does its own work. It goes on replicating. It goes on dividing, and it causes a deep-seated infection. Okay, so this is for this reason the option is option B, more likely to cause a deep-seated infection. Okay, hope it is clear so far. Hope clear so far. We are moving on to the next question. Okay, just let me know, is it clear so far or any questions? Any questions till now? Okay, any questions are welcome in the chat box, please. Okay. So next question. Virus-mediated transfer of host DNA from one cell to another is known as. Virus-mediated transfer of host DNA from one cell to another is known as. And the options are option A, transduction, option B, transformation, option C, transcription, and option D, integration. What's the right answer? Right answer option A, transduction. So shall we see what's the right answer? And the right answer is yes, option A, transduction. Okay, so when the host DNA, when the DNA is being transferred from one cell to another, so you always try to remember when you see the word transduction, there are many types of transformation, transduction, transformation, transcription, translation, transversion, transfection, lots of lots of trans are there for confusion. అవన్నీ ఎందుకు ఉన్నాయని మనల్ని కన్ఫ్యూజ్ చేయడానికి. Okay, but we don't need to confuse. We should know each of them in detail. If we know each of the meanings of that particular terms clearly, then there is no chance of confusion and we can go on with the right answer. Yes. And option A, transduction. Always remember, whenever you see a word duction, so immediately go for virus. Virus-mediated transfer of host DNA is known as transduction. So what is transformation? What is transformation? Transformation is also transfer of DNA from one cell to another. Transformation is also transfer of DNA from one cell to another, but it is direct uptake of DNA from the external environment by the bacteria. Okay, if a bacteria directly engulfs or directly uptakes the DNA from external environment by its cell membrane, that is known as transformation. Direct uptake of host DNA by the bacteria is known as transformation. What is transcription? Yes, everyone knows this. What is transcription? Transcription. I need an answer for this. What is transcription? Transcription, formation of RNA from DNA. Yes, DNA to mRNA. Very good. Formation of DNA, conversion or formation of a mRNA from a DNA is known as transcription. Yes, very good. And what is integration? What is integration? Integration is also related to virus. Okay, this integration is also related to virus. What happens? The viral DNA is incorporated into the host. Okay, incorporation of viral DNA into the host. Transfer of viral DNA to the host is known as integration. Okay, so here the answer is when the host DNA is transferred from one cell to another by the mediation of virus, the answer will be transduction. We'll see the various, yes. So these are various, so this is DNA to DNA, conversion of DNA to DNA, formation of a DNA, one strand from another strand is known as DNA replication. Formation of mRNA from DNA is known as transcription. Formation of protein, this conversion of RNA to protein, formation of proteins from RNA is known as translation. Okay, this is hope the complete screen is clearly visible. Yes. Okay, so direct uptake, here we can see direct uptake of the host DNA by the bacterium is known as transformation, and when the transfer is mediated by a virus or a bacteriophage, it is known as transduction. Okay, conjugation. What is conjugation? Attachment of bacteria is known as conjugation, and transfection. What is transfection? Transfection is electrical shock. When the DNA transfer is mediated by an electric shock, it is known as transfection. Okay, when it is mediated by virus, it is known as transduction. When it is mediated by electrical shock, it is known as transfection. Okay, and what is the transversion? What is the transversion? Transversion is, so we all know in a DNA or in a genetic material there are various bases. There are various nitrogen bases like purines and pyrimidines. Okay, purines and pyrimidines, yes. Conversion of a purine to a pyrimidine is known as a transversion. Conversion between purine to a pyrimidine is known as a transversion, and conversion between a purine to another purine is known as transition or translation. Transition. It is known as a transition. Okay, so just now we have discussed so many transes: transcription, translation, transformation, transduction, transfection, transversion, transition. So many trans. Don't get confused. Note down each of these in detail. Please take a screenshot if possible, and please note down what is each term means. Okay, so moving forward, question number 8. The following are aminoglycoside antibiotics except. Okay, in the question paper it was mentioned as aminoglycoside antibodies. Please correct, it is the following are aminoglycoside antibiotics except. Except what? And the options are, it's a direct question. Direct question, and the options are option A amikacin, B neomycin, C streptomycin, and D antiglobulin. Antiglobulin, what is the right answer? Yes, right answer please. You all must have known this. Aminoglycoside antibiotics. All the mentioned are antibiotics except. No, gentamicin is not an option here. We don't have an option of gentamicin, please. Yes. It is option C, antiglobulin. Antiglobulin is not an antibiotic at all. Leave whether it is an aminoglycoside or a macrolide or a beta-lactam type. But antiglobulin is not an antibiotic itself. Okay, so it is a easy and direct question, and the right answer is antiglobulin. All the others, amikacin, neomycin, streptomycin, they all belong to aminoglycoside class of antibiotics. Okay, moving forward to the next question. The following drugs act by inhibiting cell wall synthesis of microorganisms. Very, very important question. I just now told you the mechanism of action of enzymes and antibiotics is a primary concern at this stage, because we have only 1 month of time for the upcoming Gpat examination. At this time, you need to concentrate more only on these factors. Only on these factors. Read the classification, read their mechanism of action and their category. That's it. Don't go for extensive study, because if you are starting your preparation now, if you are going for your preparation now, concentrate only on these and you will definitely crack some good number of questions. Okay, and options are gentamicin, option A gentamicin, B cefuroxime, C amphotericin B, and option D erythromycin. Option D erythromycin. So what is the right answer? Right answer for this question: drugs that act by inhibiting cell wall synthesis of microorganisms. Okay, and the right option is option B, cefuroxime. Yes, very good, very good. Many right answers. Okay, option B, cefuroxime. Why? Cefuroxime belongs to which class of antibiotics? Cefuroxime belongs to which class of antibiotics? Which class of antibiotics does it belong to? Cephalosporins, and cephalosporins are Cephalosporins are beta-lactam antibiotics. We should always remember whenever there is something, our option has a beta-lactam antibiotic. Beta-lactam antibiotics, they are again of two types. What are they? Penicillins and cephalosporins. Both belong to beta-lactam class of antibiotics. Any beta-lactam antibiotics, the mechanism of action of beta-lactam antibiotics is inhibiting the cell wall synthesis of microorganisms. Yes. Okay. And so, among these options, cefuroxime is a beta-lactam antibiotic and it is a cephalosporin and it acts by inhibiting the cell wall synthesis of microorganisms. What about gentamicin? Gentamicin, which kind of an antibiotic is it? Which class of antibiotic does it belong to? Gentamicin belongs to the class of yes. Please respond faster. Gentamicin belongs to the class of it is an aminoglycoside. Gentamicin belongs to the class of aminoglycoside antibiotics. What is their mechanism of action? What is the mechanism of action? Aminoglycosides, they inhibit bacterial protein synthesis. Inhibition of bacteria. So just now, cefuroxime is inhibiting cell wall synthesis, and aminoglycosides are inhibiting protein synthesis of bacteria by binding to by binding to 30S subunit of ribosomes. Very good, sharp. Yes. And what is amphotericin B? 30S ribosomal subunit. Yes, very good. Option C, amphotericin B. Amphotericin B is a what kind of an antibiotic is? Yes, it is an antifungal agent. Amphotericin B, it is an antifungal agent. I am stuck in. Yes. Is there any disturbance? Any disturbance? Am I stuck somewhere? Yes, amphotericin B is an antifungal agent. Okay, how does it act? It acts by disruption of the fungal cell membrane. It is okay now? Okay, thank you very much for the immediate feedback. Yes, thank you. How does amphotericin B? It acts by disruption of fungal cell membrane. It is an antifungal agent. It acts by disrupting the fungal cell membrane. Fungal cell membrane disruption. Okay. And erythromycin, yes. Before I asked, I got an answer. Erythromycin, yes, it belongs to macrolide class of antibiotics. And what do macrolides do? How do they act? They act by inhibiting the protein synthesis again by binding to 50S subunit of ribosomes. Okay, erythromycin belongs to macrolide class of antibiotics. It is a protein synthesis inhibitor. It acts by binding to 50S. Yes, 50S by preventing the growth. That's what, by binding to 50S ribosomal subunit of microorganisms. So, for this question, the right answer is option B, cefuroxime, a beta-lactam antibiotic which inhibits the cell wall synthesis of microorganisms. Moving forward to the next question. Direct question, one more direct question. A causative organism for syphilis is? Causative organism for syphilis is, and the options are Clostridium tetani, and Immunoglobulin. Yes, and the right answer is option C, Treponema pallidum. Very good. That was the right answer. And Clostridium tetani is responsible for Clostridium tetani causes. My voice is not clear. Okay. Okay, let me check my connection. Yes. Is it clear now? Is it okay now? Is it okay now? Tetanus. Okay, okay. Okay, thank you. Clostridium tetani. Option A, Clostridium tetani causes tetanus. Yes, very good. Option B. Now it is okay. Thank you. Bacillus pertussis causes. Option B. Bacillus pertussis is responsible for. What does it cause? Causes pertussis, also known as whooping cough. Whooping cough. Whooping cough. Yes. And Treponema pallidum. The question, it causes syphilis. And Vibrio cholerae causes? Vibrio cholerae causes? Yes, we all know that. Cholera, yes, Vibrio cholerae causes cholera. This was a direct question. Very, very important question. Syphilis is a kind of, what kind of a disease is it? What kind of a disease it is? A STD, sexually transmitted disease. Moving forward to the next question. Yes, this is Treponema pallidum. It is a gram-negative bacterium. Yes, it is an STD. Yes, very good. Okay, moving forward to the next question. The following class of drugs are called as centrally acting sympatholytics. Centrally acting sympatholytics, and the options are. Alpha 1 blockers, option B alpha 2 blockers, option C alpha 2 agonists, and option D beta 1 blockers. Beta 1 blockers. So what is the right answer? Centrally acting sympatholytic agents. Right answer is, what's the right answer? And yes, the right answer is very good. It is option C, alpha 2 agonists. Okay, alpha 2 agonists. Yes, very good. Yes, even with examples, very good. It is clonidine. Nice, nice. Okay, so here all the drugs, alpha 1, alpha 2, alpha 1 blockers, alpha 2 blockers, alpha 2 agonists, beta 1 blockers, everything. All these belong to sympatholytic agents. All these are sympatholytic agents. Okay, but only one of these is centrally. Our question is about centrally acting sympatholytics, and only one is centrally acting sympatholytics, that is alpha 2 agonist. That is, yes, example is clonidine. Very good. Okay, moving forward to the next question. Very interesting and very important question once again. Very important, interesting, and slightly tricky. Okay, anti-arrhythmic drug with local anesthetic action. Question number 12. Anti-arrhythmic drug with local anesthetic action, and the options, here goes our options, are verapamil, bretylium, procainamide, and disopyramide. Verapamil, bretylium, procainamide, and disopyramide. Anti-arrhythmic drug with local anesthetic action. Yes, option C, option C, option C, option C, yes. And the right answer is option C, procainamide. Okay, procainamide. So again, once again, all the options mentioned here are option A, verapamil, bretylium, procainamide, disopyramide. All are anti-arrhythmic drugs. Okay, but only one of these poses a local anesthetic action. Please go through the question carefully while answering. Always go through the question carefully. Read the question twice before answering. Okay, and the option is option C, procainamide. Okay, which class of antiarrhythmic drug is procainamide? Which class of an antiarrhythmic drug is procainamide? How many classes of antiarrhythmics are there? Antiarrhythmic drugs. How many classes of antiarrhythmic agents are there? Antiarrhythmics are classified into how many classes? 4 classes. Yes, 4 classes. Very good, very good. And procainamide is, yes, someone has mentioned it. It is class 1A. Class 1A type of antiarrhythmic drug. It is a class 1A belongs to sodium channel blockers. Class 1A antiarrhythmic agents, they are sodium channel blockers. Okay, and verapamil, yes, sodium channel blocker. And verapamil belongs to class, which type of antiarrhythmic agent? Which class? Verapamil, class 4 calcium channel blocker. Yes, calcium channel blocker, it is class 4. And bretylium is class 3 potassium channel blocker. It is class 3. Disopyramide, again class 1A sodium channel blocker. It is a sodium channel blocker. There are 4 classes of antiarrhythmic agents, 1, 2, 3 and 4, and procainamide belongs to class 1A. Okay, next class. Question number 13. Irbesartan is an antihypertensive drug. It will act by inhibiting what? Irbesartan. Sartans, they are known as, all the sartans are known as ARBs. They are known as ARB. ARB is nothing but angiotensin receptor blockers. Okay, and the options here are angiotensin 2 receptor subtype 82, angiotensin 2 receptor subtype 81, angiotensin 1 receptor subtype 81, and angiotensin 1 receptor subtype 82. So what's the right answer? Irbesartan. To which class it belongs to? Angiotensin receptor blocker. It is an angiotensin receptor blocker. Which angiotensin receptor blocker? Which type of receptor? Angiotensin receptor 1 or 2? 1 or 2? Angiotensin receptors are of 2 types, type 1 and type 2. And sartans belong to which type? And type 2 is again divided into 81 and 82. So sartans, yes, all the sartans, angiotensin receptor blocker anochindi ante, when it is a sartan, whether it may be a valsartan, telmisartan, losartan, irbesartan, what type of a sartan it might be. It is a angiotensin receptor 2 blocker. Angiotensin receptor 2 blocker subtype 81. Okay, and the right option is angiotensin 2 receptor subtype 81, option B. Angiotensin 2 receptor subtype 81 blockers. Okay, was it clear? Okay, and the mechanism by which pyrantel palmoate is effective for the treatment of Necator americanus. Necator americanus, it is a worm. It is also known as hookworm. Necator americanus is also known as hookworm, and the disease is named after it, hookworm disease. So the pyrantel palmoate is a drug of choice in hookworm disease, and it acts by which mechanism? How does it act in treatment of hookworm disease? And the options are it interferes with cell wall synthesis, it interferes with cell division, it inhibits the neuromuscular transmission, and option D, interference with protein synthesis, and the option D, T polarizes the neuromuscular nematodes. Yes, very good, and the option is, right answer is option C. Very, very good. It acts by inhibiting the neuromuscular transmission. Okay, pyrantel palmoate is effective by inhibiting the neuromuscular transmission in a hookworm disease. Yes, it depolarizes the neuromuscular junction in nematodes. Very good, very well answered. Moving on to the next question. Next question. The active metabolite formed from proguanil is. I got the right answer everywhere. Wherever I am discussing this question, I got the right answer everywhere for this question. Let me see now. Right answer everywhere for this question. The active metabolite formed from proguanil is. Options are A. Nitroguanil, B. Cycloguanil, C. Chloroguanil, and D. Chlorproguanil. Yes, okay, even I got right answers here too. Okay, I am very happy about this. Proguanil, the active metabolite formed from proguanil is cycloguanil. Okay, what kind of a drug is proguanil? What kind of a drug is proguanil? Proguanil or cycloguanil? What is it used in? What is it used in? What is its action? What is its category? Yes, it is a anti-malarial agent. Very good. Yes, it is an anti-malarial agent. Right. Super. It's very good. Dihydrofolate reductase inhibitor. Fantastic. Fantastic. It is an anti-malarial and acts by inhibiting the dihydrofolate reductase enzyme. Very good. Nice concepts. The answer is B. Cycloguanil. Yes. Question number 16. Next question. Antibiotic that inhibits bacterial RNA synthesis. Antibiotic which acts by inhibiting the bacterial RNA synthesis is and the options are A. Erythromycin, B. Rifampicin, C. Chloramphenicol, and D. Imipenem. What's the right answer? Right answer for this question number 16. Antibiotic inhibiting bacterial RNA synthesis. Yes. And the answer is rifampicin. Okay, always try to remember. Whenever something is inhibiting RNA synthesis, RNA, R, and rifampicin starts with R. Try to correlate. Remember, yes, it blocks the initiation of RNA synthesis. Yes, it inhibits the bacterial DNA-dependent RNA polymerase enzyme. It inhibits the DNA-dependent RNA polymerase enzyme, rifampicin. Remember, RNA synthesis. So immediately you need to correlate rifampicin. R for RNA, R for rifampicin. Yes, DNA-dependent RNA polymerase enzyme. Very good. Nice. And what about erythromycin? Erythromycin, how does it act? What does it inhibit? Erythromycin is a macrolide. Yes, erythromycin is a macrolide. It inhibits the bacterial protein synthesis by binding to 50S subunit of ribosomes. Yes. And chloramphenicol, how does it act? It also inhibits the bacterial protein synthesis by binding to 50S and 70S subunits of ribosomes. Yes, 50S and 70S subunit of ribosomes. What about imipenem? Imipenem is a beta-lactam antibiotic. It is a beta-lactam antibiotic. And just now we have discussed what do beta-lactam antibiotics do? They act by inhibiting the cell wall synthesis of microorganisms. Okay, imipenem is a beta-lactam antibiotic. It acts by inhibiting the cell wall synthesis of microorganisms. Okay, moving forward to the next question. Yes, this is how it acts. RNA synthesis inhibitor, rifampicin, rifamycin, rifaximin, rifapentin. They all inhibit the cell wall. Yes, very good. Yes, next. Question number 17. Clavulanic acid is important because. Okay, so here the question is clavulanic acid. What is true about clavulanic acid? And the options are it easily penetrates bacterial cell membrane, is specific for gram-positive bacteria, is a potent inhibitor of cell division, or it inactivates bacterial beta-lactamase. Clavulanic acid. There are certain points given about clavulanic acid which is true about clavulanic acid here. Yes, what's the right answer? What's the right answer? Clavulanic acid. It is a beta-lactamase inhibitor. Please remember. Yes, it is a beta-lactam drug. It is a beta-lactamase inhibitor, clavulanic acid. And clavulanic acid always, it does not act individually. It is not used independently. It does not act individually. It is always used in combination with a penicillin. Clavulanic acid is always active when used in combination with a penicillin. Mostly amoxicillin. We usually see amoxicillin, potassium clavulanate. Clavulanic acid is activated in its salt form potassium clavulanate. Okay, it is a beta-lactamase inhibitor, acts in combination with a penicillin antibiotic, like mostly amoxicillin. And the next question is yes, very very important question. Question number 18. Rifampicin is obtained from. And the options are Streptomyces rhinosus, Streptomyces aureus, Streptomyces mediterraneae, and Streptomyces norsci. Okay. Streptomyces rhinosus, aureus, mediterraneae, and norsci. What's the right answer? Option C, option B. Yes. And the right answer is Streptomyces mediterraneae. So rifampicin is obtained from Streptomyces mediterraneae. Rifampicin is obtained from Streptomyces mediterraneae. Okay, and the other name for Streptomyces mediterraneae is, as someone has given an answer, is it is also known as Amycolatopsis rifamycinica. Okay, Streptomyces mediterraneae. It is also known as. Am I audible? Am I audible? So it is also known as. Yes, someone has mentioned Amycolatopsis mediterraneae, or it is also known as Amycolatopsis rifamycinica. Okay, Amycolatopsis mediterraneae or Amycolatopsis rifamycinica. Okay, so and Streptomyces rhinosus, what does it give rise to? Streptomyces rhinosus, option A. Streptomyces rhinosus. Antibiotics produced from Streptomyces rhinosus. Tetracyclines, oxytetracycline, especially oxytetracycline, all the tetracyclines. Okay, Streptomyces norsci. Okay, remember, Streptomyces norsci. N stands for norsci, and N stands for it gives rise to an antibiotic, nystatin. Antibiotic produced from Streptomyces norsci is nystatin. Yes, nystatin. Yes, very good. N for norsci and N for nystatin. Streptomyces aureus produces azithromycin. Okay, so rifampicin, as we have studied here, it is obtained from Streptomyces mediterraneae. Okay, and question number 19. Moving forward to the next question. Muscarinic receptors are located in. Muscarinic receptors are located in, and the options are autonomic ganglia, skeletal muscle neuromuscular junctions, autonomic effector cells, and sensory carotid zone. What's the right answer? Muscarinic receptors are located in what? Cholinergic nerve terminals. Yes. Autonomic effector cells. And the right option is muscarinic receptors are located in autonomic effector cells. Very good. Autonomic effector cells. So what are the receptors located? It's option C, autonomic effector cells. What are the receptors located in autonomic ganglia then? Autonomic ganglia. What are the receptors located? In effector cells, muscarinic receptors are located. In autonomic ganglia, what are the receptors located? If it is option A, what is the right answer? Autonomic ganglia consists of which type of receptors? Which type of receptors? Nicotinic receptors. Yes, nicotinic receptors. Very good. Is nicotinic receptors. Okay, moving forward to the next question. With the next question, is the mechanism of action of indirectly acting cholinomimetic agents is. The mechanism of action of indirectly acting cholinomimetic agents is, and the options are option A, binding to an inactivation of muscarinic and nicotinic receptors. Option B, inhibition of hydrolysis of endogenous acetylcholine. Option C, stimulation of action of acetylcholinesterase. And option D, releasing acetylcholine from its storage sites. What is the right answer? Right answer. Mechanism of action of indirectly acting cholinomimetic agents. So what do you mean by cholinomimetics? Other names for cholinomimetics? What are cholinomimetics also known as? Cholinomimetics also known as parasympathomimetics. Cholinomimetics, yes, are also known as parasympathomimetics. What do they do? Parasympathomimetics, what do they do? They mimic, mime. Mime is something in imitation or mimicking something. They imitate the action of parasympathetic nervous systems or the neurotransmitters of parasympathetic nervous system. Okay. So there are two types. Again, parasympathomimetics or cholinomimetics agents. They are again of two types. What are they? Directly acting and indirectly acting. These are again, they are of two types. Direct acting and indirect acting. Okay. So here the question is about indirect cholinomimetic agents and their mechanism of action. Their mechanism of action, what is the right answer? I didn't get a right answer so far. No right answer so far. No right answer so far. And the right answer is, it inhibits the hydrolysis of endogenous acetylcholine. Okay, inhibition of the hydrolysis. So when acetylcholine, which is in circulation, when it is hydrolyzed, its action is stopped. Okay, when it is hydrolyzed, its action is yes, it breaks down. Okay, so but what do these indirectly acting cholinomimetics? They are cholinomimetics, means they enhance the action of this acetylcholine. What they do? They enhance the action or they support the action of acetylcholine. So how do they support? They act by inhibiting. They prevent the hydrolysis of acetylcholine. Okay, thereby they mimic the cholinomimetic action. Okay, example of indirectly acting cholinomimetic agents. Example of indirectly acting cholinomimetic agents. Examples of indirectly acting cholinomimetic agents. Yes, they increase the duration of action. Very good, right? Very true. What's the example? Indirectly acting cholinomimetics, neostigmine, physostigmine, they are all indirectly acting cholinomimetic agents. Okay, and the example for directly acting cholinomimetics, physostigmine is neostigmine and physostigmine. For directly acting example, pilocarpine, methacholine. I'll write down methacholine. Okay, these are directly acting sympathocholinomimetic agents. Okay? Yes. So if the option is C, stimulation of action of acetylcholinesterase. Stimulation of action of acetylcholinesterase it is caused by not by cholinomimetics, cholinolytics. Parasympatholytics do stimulate the acetylcholinesterase. So it causes hydrolysis. That is lytic action, not mimetic action. Okay. Okay, question number 21. Question number 21. Drug of choice for the treatment of acute organophosphate poisoning is very, very important question. Drug of choice for treatment of acute organophosphate poisoning. And the options are. Option A, atropine, pralidoxime, neostigmine, and tubocurarine. Atropine, pralidoxime, neostigmine, and tubocurarine. What is the drug of choice among these options? Yes. And the right option is option A, atropine. Yes. Right, very good. Both atropine and pralidoxime, both are used in the treatment of acute organophosphate poisoning. But here the question is drug of choice. First line of choice is atropine. Okay, atropine is used in the treatment of acute organophosphate poisoning as a first line of drug. Okay, question number 22. Next question. Question number 22. Yes. Drugs belong to glycopeptide class. Drug that belong to glycopeptide class. Glycopeptides class. And the options are. A, vancomycin, B, lincomycin, C, neomycin, and D, carbenicillin. Okay, many answers. Yes. And the right answer is vancomycin. Vancomycin belongs to glycopeptide class of antibiotics. Okay. And lincomycin? Yes, teicoplanin. Yes. Also other antibiotics in glycopeptide class are, yes, very good. Teicoplanin, telavancin. Yes, very good. And what kind of an antibiotic is lincomycin? Lincomycin belongs to which class? Which class of antibiotics? Lincomycin, it is a lincosamide class of antibiotic. Yes, it is lincomycids, lincosamides. Neomycin, is a aminoglycoside. Yes, carbenicillin. Option A, carbenicillin belongs to penicillins. Yes, it is a penicillin kind of antibiotic. Okay, let's move on. Yes, peanuts. Yes, very good, right. Belongs to peanuts, carbenicillin. It is a beta-lactam antibiotic penicillin. 23. Question number 23. Mechanism of action of trimethoprim. Mechanism of action of trimethoprim is. Trimethoprim is, and the options are inhibition of cyclooxygenase, inhibition of dihydrofolate reductase, inhibition of dihydroteroid synthase, and inhibition of DNA gyrase. Yes, blocking the reduction. Yes, very good. Very good. More answers, please. Okay. And the right answer is yes, it blocks the reduction of dihydrofolate to tetrahydrofolate. That means inhibits dihydrofolate reductase. Okay. Option B, inhibition of dihydrofolate reductase inhibitor, trimethoprimase. Okay. So, any example for inhibition of cyclooxygenase? Inhibition of cyclooxygenase. Any examples? Cyclooxygenase inhibitors, COX, cyclooxygenase COX inhibitors, COX inhibitors. Inhibition of cyclooxygenase is usually caused by NSAIDs. NSAIDs. They inhibit cyclooxygenase. Okay. Any examples? Yes. Any examples for aspirin? Yes. Very good. Examples for selective COX inhibitors. Selective COX inhibitors. Examples. Cyclooxygenase is of two types, COX-1 and COX-2. Okay. Selective COX-2 inhibitors. Examples. Examples for selective COX-2 inhibitors. Celecoxib. Celecoxib. Selective COX-2 inhibitors. Cyclooxygenase selective inhibitors. COX-2 inhibitors. Celecoxib. Okay. Yes. Very good. Very good. Yes. Agents which inhibit dihydroteroate synthase. Option C. Inhibition of dihydroteroate synthase. Dihydroteroate synthase is caused by sulfonamides. Sulfonamides. Yes, cause the inhibition of dihydroteroate synthase. Inhibition of DNA gyrase. One more important question. Very, very important question. The agents which act by inhibiting DNA gyrase. Antibiotics or antibacterial agents which act by inhibiting bacterial DNA gyrase. What are those agents? Fluoroquinolones. Very good. Fluoroquinolones. Inhibition of DNA gyrase is caused by fluoroquinolones. Examples of fluoroquinolones: ciprofloxacin, norfloxacin. Okay, all floxacins. Okay. So we are moving to the next question. Next question. Which of the following? Yes, fluoroquinolones. Very good. That is also a very, very important question. Agents that act, fluoroquinolones act by inhibiting DNA gyrase. Okay, ciprofloxacin. Very good. Right answer. 24. Which of the following penicillin is used to treat the infections caused by Pseudomonas aeruginosa? Pseudomonas aeruginosa infections are treated by penicillins like option A amoxicillin, B piperacillin, C methicillin, and D benzyl penicillin. Which is the right answer? And right answer is C. Yes, Praveen. Good. And the right answer is option B, piperacillin. Okay, remember, even this you need to remember. Pseudomonas aeruginosa starts with P and piperacillin. Okay, piperacillin, Pseudomonas aeruginosa, P in Pseudomonas aeruginosa, P in piperacillin. Pseudomonas aeruginosa infections are treated by using piperacillin. Yes, very good. Okay, and question number 25. What is the significance of decreased plasma protein binding? Decreased plasma protein binding. The question, I think in the question paper it is not clear. The word decreased is not mentioned. Please correct the question. Significance of decreased plasma protein binding. And the options are enhances the rate of absorption, enhances the rate of distribution, enhances the metabolism, and enhances excretion and action. Which is the right answer with respect to decreased plasma protein binding? Yes. Yes, Rajvardhan, Soumya, Praveen. Yes, very good. Very good. Yes. When there is a decreased plasma protein binding, more free drug is available in the blood. More free drug is available in the blood, and it enhances the rate of distribution, and also volume of distribution is enhanced. Okay. Yes, that was the right answer. Enhances the rate of distribution. Okay. Okay, nice. Next question. Question number 26. One more very important question. Which of the following is the highly toxic metabolite of paracetamol? One of the following is a highly toxic metabolite of paracetamol. Paracetamol may give rise to many metabolites. One of the following is the most toxic metabolite. And it is, the options are N-acetyl P-benzoquinoneamine, N-ethyl P-benzoquinoneamine, N-acetyl P-benzoquinone and D-N-acetoxy P-benzoquinoneamine. Right answer is, what is the right answer option? Please mention the option, please. Yes, it is N-acetyl P-benzoquinoneamine. Yes, right answer. And the right answer is option A. Okay, so acetaminophen, as we all know, acetaminophen, also known as paracetamol, it undergoes metabolism to give many different metabolites. Okay, if it undergoes conjugation, it gives a glucuronide one. If it undergoes direct glucuronide conjugation, it gives a non-toxic metabolite. If it undergoes a sulfate conjugation, even then it gives a non-toxic metabolite. Okay, but if it does not undergo these type of conjugations, and the product is N-acetyl P-benzoquinoneamine, it is the most NACP, also frequently commonly known as NACP. NACP is the highly toxic metabolite of paracetamol. Okay, which leads to usually, which toxicity does paracetamol cause? Toxic metabolites of paracetamol causes what type of toxicity? What type of toxicity? Hepatotoxicity. Very good. It causes hepatotoxicity. Yes, toxicity to liver or hepatotoxicity, and that is nothing but NACP. N-acetyl P-benzoquinoneamine, liver damage, liver toxicity. Yes. Okay, very good. So all of you are following it so well. And question number 27. 27. What is the correct order of bond strength from strongest to weakest? Correct order of bond strength from strongest to weakest. You all must be knowing this very well. Many must have answered it right. Bond strengths, correct order of bond strength, strongest to weakest. Okay, option A, van der Waals, hydrogen, ionic, covalent. Ionic, then covalent, then hydrogen, then van der Waals. Covalent, greater than hydrogen, greater than ionic, greater than van der Waals. And covalent, greater than ionic, greater than hydrogen, greater than van der Waals. Which is the right answer? Right answer. Yes, right answer. Okay. Most of them answered it to be D. Yes, and Rajvardhan. Yes, answered it option B. We'll see. We'll see which one is the right answer. And the right answer is option B. Yes. Ionic bond, strongest of all kinds of bonds is ionic bond is the strongest of all, followed by covalent bond, followed by hydrogen bond, and followed by van der Waals forces. Okay, we all know, we always study whenever we go through van der Waals forces. Weak van der Waals forces of attraction. Van der Waals forces are weakest of all the attractive forces. Okay, van der Waals forces are weakest of all the attractive forces and ionic bond being the strongest. Okay, yes. This was a direct question. Please remember the sequence: ionic bond strongest, followed by covalent, followed by hydrogen, and followed by van der Waals forces. Okay. Next, question number 28. This is an assertion reason question. Question related to assertion and reasoning. And 28 assertion. Assertion is pethidine should not be used for long periods. Okay. Pethidine should not be used for long periods. What kind of a drug is pethidine? What kind of a drug is pethidine? Pethidine. What kind of a drug is pethidine? Please answer. Yes, it is an opioid analgesic. Right, very good. True. Pethidine is an opioid analgesic. Okay. The assertion is it should not be used for long periods. Okay. Yes, it is an opioid analgesic. Right, true. Reason is long-term use of opioids can result in dependence. Is the assertion right? Pethidine, can it be used for long periods? Is the assertion right? Pethidine, can it be used for long periods? No. Yes. So assertion is right. Assertion is true. Reason: long-term use of opioids can result in dependence. Long-term use of opioids, as you all know, many opioids, morphine, codeine, and all these are. Yes, morphine, codeine, all these belong to opioid class. So long-term use of opioids, can it result in dependence? Will it result in dependence or not? Yes, is the reason true? Is the reason true? Yes. So we'll see the options. We'll see the options. Yes. Both assertion and reason are true, and reason is correct explanation of assertion. And option B, both assertion and reason are true, and reason is not the correct explanation of assertion. C, assertion is true and reason is false. D, both assertion and reason are false. So which is the right answer of these options? Of these options, which one is the right answer? Yes, someone answered it C, someone answered it A, and more answers. A. Yes, and the right answer is B. Right answer is B. Okay. So we know that both assertion and reason are true. Pethidine should not be used for long periods is true. And reason long-term use of opioids can result in dependence is also true. But here for pethidine, this is the not right reason. Okay, pethidine should not be used for long periods because it does not result in dependence, because it is not a long-term used opioid like that of morphine, codeine and all. Pethidine is not prescribed for long periods. Okay, pethidine should not be used for long periods because it causes cramps and seizures. It results in cramps and seizures. That is the reason it should not be used for long periods. So what's the answer? Both assertion and reason are true, but reason is not the correct explanation of assertion. Okay, here, and this is answer option B. Yes, it causes withdrawal symptoms, but it is not used for long periods. If it is used for long periods, pethidine, it causes seizures, it causes cramps. Okay, so it does not usually result in dependence. Yes, and question number 29. Which of the following actions is ascribed to delta type of opioid receptors? Delta type of opioid receptors. So what is the action? Which of the following actions? So it is a supraspinal analgesic. Option B, respiratory depression. C. Results in euphoria. D. Reduced intestinal motility. So, yes, of opioid receptors, which of the following is true? I can see some answers. What are they? What are they? Yes, and the right answer is supraspinal analgesic. Yes, supraspinal analgesic. Very good. How many types of opioid receptors are there? How many types of opioid receptors? Very, very important question. Very important concept in terms of competitive examinations. How many types of opioid receptors are there actually? Opioid receptors are classified into how many types? How many types? Which of? Four types, yes. Four types. What are they? Four types of opioid receptors: M type, D type, K type, and the last one is very, very important, nociceptin. Nociceptin. M is nothing but mu type. Mu type of opioid receptor. D is nothing but a delta type of opioid receptors. K is kappa type of opioid receptor. And the fourth type is nociceptin. Okay? Yes. So, of these, delta receptor, which kind of action does it exhibit? It exhibits a supraspinal analgesia, spinal and supraspinal analgesia type of action. Okay, respiratory depression is caused by? If the option is respiratory depression, it is caused by? Yes, even yes, Z type is also there, zeta. Z type, zeta is also, it is a new type of opioid receptor, not very much prominent. These four are very prominent. If it is the second option, respiratory depression, which type of receptors are responsible for respiratory depression? Yes, mu. M type or mu type are responsible for respiratory depression. Euphoria. Euphoria is also related to mu type of opioid receptors. Reduced intestinal motility. Reduced intestinal motility is due to which kind of opioid receptors? Reduced intestinal motility is kappa receptors. Okay, kappa receptors are responsible for reduced intestinal motility. Okay, very important. Remember nociceptin. It is also known as NOD. Nociceptin opioid receptors, NOR. Nociceptin is responsible for very, very important. Nociceptin is responsible for memory impairment. This is responsible for memory impairment. Okay? Clear all of you? Clear all of you? Shall we move on to the next question? Shall we move on to the next questions? Please answer. Yes, okay. Thank you very much for the response. Okay, question number 30. Yes, okay. Thank you very much. Question number 30. 5-HT1A agonist that is used as an anxiolytic. Anxiolytic 5-HT1A agonist. Okay, and options are: option A is piperone, B buspirone, C diazepam, and D zolpidem. D zolpidem was the right answer. 5-HT1A agonist that is used in treatment of, that is used as an anxiolytic agent. What is it? Yes, anxiolytic. Anxiolytic, which is a 5-HT1A agonist. So listen, all the options mentioned here, A, B, C, D, all are anxiolytics. Yes, all are anxiolytics, but which belongs to the class of 5-HT1A agonist? Yes, one of the answers, and the answer is option B, buspirone. Buspirone, yes, buspirone belongs to 5-HT1A agonist that is used as an anxiolytic. What is piperon? Option A is piperon. What is it? It is also an anxiolytic. It is an antipsychotic. Piperon, it belongs to butyrophenone. It belongs to butyrophenone class of anxiolytics. Butyrophenone class. Buspirone is the 5-HT1A agonist. Diazepam. Which class does it belong to? Diazepam. Diazepam belongs to the class of what? Class of, yes, benzodiazepines. Very good. Very, very important class of anxiolytics. Benzodiazepines, diazepam. Very good. And zolpidem. Zolpidem is a GABA receptor agonist. Zolpidem, it is a, yes, it is a non-benzodiazepine, sedative, hypnotic. It is a GABA receptor agonist. GABA receptor agonist, which acts as a sedative, hypnotic. It is also an anxiolytic agent. So all are anxiolytic agents, but 5-HT1A agonist is buspirone. Yes. Okay. Very good. Stop this one. So all of you, before going to the next question, there is a slight problem with the streaming here, and part 2, next part, the further part will be continued in tomorrow's class, same time, 6 p.m. Is that okay? Is that okay, all of you? Shall we continue tomorrow from question number 31? Yes. Need more answers? Shall we continue tomorrow? Yes. Why do you need my name now? What for? Yes, yes, definitely. I'll let you know my name by the end of the session, by the end of tomorrow's session. Yes, okay, there is a slight streaming problem, and the remaining questions will be discussed by 6 p.m. sharp tomorrow. Is that okay? Shall we wind it off here? Okay. Okay, so we are ending the live stream now here, and will be continued tomorrow, and the link will be shared. Thank you all very much for your patient listening. Have a good time. Good night.